Hello, my name is Sahid Akyuri. I am from Lviv. I am presenting a method of prosthetic vision developed with my mentor Koldun Victor. To begin with, according to World Health Organization report, each fifth person has sight problems, and each 200 is completely sightless. And unfortunately, to move safely, they still need to use a stick or ask for help from a guide. That is why we started searching a method to help them. The method is transmission of information through acoustic channel. During the research, we have considered two different methods of information transmission, verbal form and sound of notes. As it proved to be, verbal form has several significant drawbacks, and to better understand them, we need to go into the structure of human's ear. The ear consists of thousands of physical resonators, which are irritated by fluctuations of specific frequencies. Thus, when we hear a sound of note, which is monotonous, less signals are perceived by our brain. However, words influence more receptors and use more brain resources. The other advantage of the notes is that they are easily processed by brain. As they consist of phonemes, such monotonous sounds are decoded by the ear and directly transmitted to the decision-making unit, while words need to be divided in that phonemes compared with already existing ones, and only after all that processes may be transmitted to the decision-making unit. Also, as notes are simpler than words, the human ear can easily transmit several notes simultaneously. That allows us to notify a person about several obstacles around him at once. However, as words overlap, it is impossible to understand more than one phrase. During the research, we faced a question whether by giving a person ability to hear the obstacles, we will not block her hearing abilities. Luckily, we don't. For telephone communication experience, we know that after cutting several frequencies from the signal, its intelligibility does not suffer. So, using these frequencies to transmit information as channels, we allow the person to hear and to perceive information about obstacles around him. Now let's talk about the method of coding information into the sound of notes. To do this, we have divided the space around the person into 12 sectors and assigned a specific notes to each of them, the volume of which shows the distance to the nearest obstacle in the sector. Also, to improve the accuracy of the system in the vertical plane, it is possible to divide each sector by the angle and to the horizontal, upper, middle and bottom one, and assign to the parts of the sectors octaves. Here is a picture of a cafe. You may see some tables on the right and the left sides of it. Those sectors in which they are marked by numbers according to the distance to the obstacles. These numbers mean the volume of the proper note. As there are no obstacles in front, notes assigned to the sectors will not be played, so the user will understand that it is safe to move safely forward. To implement the proposed method, several models were created. The first prototype was based on an Arduino and has several drawbacks. The second one was based on Raspberry Pi. Usage of this platform allowed us to make the device smaller. Now the prototype uses ultrasonic sensors to gather information about surroundings. Furtherly, we want to make the device smaller and convert it into a small stripe that will be worn on a head and may be used on a daily basis. Also, we want to use a stereo vision to gather information more precisely. In conclusion, I would like to say that the conducted research and created prototypes showed that using only part of acoustic channel, we can reliably and quickly inform a person about the situation around him. This will not only allow sight-impaired people move safely, but may radically change their lifestyle. Thank you for your attention.